Another example of a forced harmonic oscillator up here on the board. This time my forcing function is an exponential times a trig function. Now, the rules haven't changed. My general solution is still going to be a solution to the associated homogeneous plus a particular solution. So, let's start by finding a solution to the associated homogeneous. So, that's going to be y double prime plus 3y prime plus 2y equals 0. The characteristic equation is s squared plus 3s plus 2 equals 0. That's s plus 2 times s plus 1 equals 0. So s is negative 2 or negative 1. So my solution to the associated homogeneous is just k1 copies of e to the negative 2t plus k2 copies of e to the negative t. Now I'm going to add to that my particular solution. In finding that, I'm going to again complexify this. Now I could, if I wanted to, just guess that I'm going to get some copies of e to the t times sine 2t plus some copies of e to the t times cosine 2t, because that's going to turn out to be what we get. That does become pretty tedious if I work with it that way. The nice thing about complexifying is that my guess is just a single exponential function. So I want to look at that and I want to say, that's the imaginary part of e to the 1 plus 2i times t. Because notice, that would be e to the t times e to the 2it. That's e to the t times cosine 2t plus I sine 2t. That's e to the t cosine 2t plus I times e to the t times sine 2t. So that right there is the imaginary part. Okay. So basically, if I have a sine or cosine multiplied by an exponential, I just know that I'm going to have a complex multiple of t in the exponent position, where now the real part is non-zero. When the real part is 0, I just get a multiple of I times t, and so the real and imaginary parts are just sines or cosines. If the real part of this number here is non-zero, then I'm also going to get an exponential function. So we're complexifying, so we're creating y tilde to be an unknown complex valued function, and saying if I take the corresponding left-hand side, its solutions would be equal to e to the 1 plus 2it. Okay, so I'm going to guess that a particular solution to my complexified equation is a copies of e to the 1 plus 2i times t, times t. And I know that my particular solution to the real valued equation is going to be yp tilde, the imaginary part, because I'm getting the signs which are part of the imaginary part. Okay, so if I make this guess, yp tilde prime would be 1 plus 2i times a e to the 1 plus 2i times t. Yp tilde double prime, I'm going to get a second factor of 1 plus 2i. So I'm going to have 1 plus 2i times 1 plus 2i times a e to the 1 plus 2i times t. So let's see what this is. This is going to give me 1 plus 2i is plus 4i, plus 4i squared is minus 4 times a e to the 1 plus 2i times t. So that's negative 3 plus 4i times a e to the 1 plus 2i times t. All right. So if I plug that in to this equation, yp tilde double prime plus 3yp tilde prime plus 2yp tilde has to equal e to the 1 plus 2I times t. So the second derivative we said was negative 3 plus 4I copies of a times e to the 1 plus 2I times t, plus 3 copies of yp prime, which was here. That's just going to make this a 3 plus 6I times a e to the 1 plus 2I times t, plus 2 copies of yp prime. That's going to make this a 2 plus 4I times a e to the 1 plus 2I times t. Oh my goodness, that's just my left-hand side. That's got to equal 1 copy of e to the 1 plus 2I times t. Okay, so there's my right-hand side. Let's see on the left-hand side how many copies of e to the 1 plus 2I times t do I have, because I can basically factor that out. Okay. I'm also going to factor out the a. Okay. And then I can see I've got negative 3 plus 4I times a e to the 1 plus 2it, plus 3 plus 6I, a e to the 1 plus 2it, plus 2 plus 4I times a e to the 1 plus 2it. So if I consolidate all of that, let's see, negative 3 plus 3 plus 2 is 2. 4I plus 6I plus 4I is plus 14I. So I've got 2 plus 14I times a e to the 1 plus 2I times t, and that's all got to equal 1 copy of e to the 1 plus 2I times t. All right, so with this, let's see. I'm going to just make myself a reminder, oops, not here, that yp is going to be y tilde p, the imaginary part. Okay, so now if this is going to work, my coefficient here has to equal 1. So 2 plus 14I times a has to equal 1. So a will be 1 over 2 plus 14I. All right, just to make life a little bit simpler, I'm going to say that that's 1/2 times 1 over 1 plus 7I. And then I'm going to multiply by 1 in the form of 1 minus 7I over 1 minus 7I. It just makes the numbers a little bit smaller. Okay. So on top, I'm going to have 1 minus 7I. On bottom, I'm going to have 2, because I factored that out, times 1. Outsides and insides cancel. Minus 49 times negative 1 is plus 49. So that's 2 times 50, so that's 100. So 1 minus 7I over 100. So the real part is 1 over 100. The imaginary part is negative 7 over 100. And of course, the imaginary part gets multiplied by the I. Excellent. So we now know what yp tilde is. Yp tilde is this number, 1 over 100 minus 7 over 100I, times e to the 1 plus 2I times t. This was just our value of a. So that is 1 over 100 minus 7 over 100I times e to the t times e to the 2it. I'm just going to bump that e to the t in front. It's just going to kind of hang out for a little while. And then times 1 over 100 minus 7 over 100I times this, I'm going to apply Euler's formula to. So that's going to be cosine of 2t plus I times sine of 2t. So we're going to get e to the t times, we're going to FOIL this out, So I'm going to get 1 over 100 times cosine of 2t. Don't really care because I'm looking for the imaginary stuff. Okay. Minus 7 over 100I times cosine of 2t. That piece I definitely like because that's contributing to the imaginary part of this. Okay. Let's see. Plus 1 over, whoops, where we go? Here we go. Plus 1 over 100I times sine of 2t. Definitely like that because that's contributing to the imaginary part. Okay. And then here I'm going to get negative 7 over 100 times I squared, which is going to become plus 7 over 100 times sine of 2t. Don't particularly care because that stuff is real. Okay. Now, all of these terms get multiplied by e to the t, but since that's a real valued function, if I started with something real, I still have something real. If I started with something imaginary, I still have something imaginary. So, I should be able to pick out what the imaginary part is. So yp, remember, was just yp tilde, the imaginary part. That's just going to be e to the t times the two things that are being multiplied by I here. So negative 7 over 100 times cosine of 2t plus 1 over 100 times sine of 2t. Remember, the I is not part of the imaginary part. It just tells me which real coefficients I want to count. Okay. I could certainly distribute the e to the t. I'm going to, I think, just keep it factored out. So plus e to the t times negative 7 over 100 cosine of 2t plus 1 over 100 sine of 2t. So that's my particular solution. We add that to a solution to the associated homogeneous, and this whole thing is the general solution to this real valued differential equation corresponding to a forced harmonic oscillator.